All right, you are going to need a calculator today. Everything we're going to be doing is math-based, so keep that in mind. All right, we are starting chapter 8, which is the last chapter before the DE test. Chapter 7, Moodle homework. Chapter 7, active homework is due by the end of the day today. So it closes at midnight. I've given time every single day to work on it. So now, so at your desk, you should have two different things. You should have a packet that has written at top. It should say POGL stoichiometry. The word POGL just means process-oriented guided inquiry learning. The way these are set up is it starts off with the simplest form of a problem, and it builds into more complex problems. So I'm going to be using this as our notes guide. This is not something that's going to be turned in. So if you need to do this right on top of it, notes do not turn in, because no matter what, I still get people turning in stuff that should be notes. Now, you should also have this sheet. This sheet is something to use kind of as a crutch as we're beginning to work on these. But it's by the time we get to the test, you should no longer need this, or you should be able to recreate it on your own. All this does is help us see the unit conversions from one thing to another. And I've already kind of shown you half of this, where we're dealing with it from one substance. So like if I'm going from particles to moles to mass, or things like that, we've done it from one half. We haven't done it from one substance to another. All right, so when we're dealing with chemical reactions, you might have something that's in the reactant that you know the amounts of, and you have something in the product that you want to know the amounts of. They can both be in the reactants, they can both be in the products, but we can go from any one thing in a chemical reaction to the other using this process. Notice that we go from moles of one thing to moles of another. All right. And so mole is that translating unit, is what we're going to be doing. So just to kind of review this, remember the relationship from mass to mole, and it should be written on your paper, but you might have to clarify it. 1 mole is the molar mass of that substance. So depending on which direction we're going, we're either going to multiply or divide by the molar mass. Particles, 1 mole is Avogadro's number.
Are you just rewriting what it said?
Yes. So 1 mole is Avogadro's number of particles. Remember, particles can be atoms, molecules, or atoms, molecules, ions, formula units, things like that. Now, we have done volume a little bit differently. This is just strictly talking about volume of a gas. If it's anything else other than volume of a gas, we have to go from volume to mass and use density. All right. But in this one, when we're talking about volume of a gas, we're going to see a relationship that 1 mole of a substance is 22.4 liters of that substance. And that's at STP, standard temperature and pressure. All right. Now, here where we're going from mole to mole, it's always going to be mole of B. B is our new substance over mole of A. And that's coming from the mole ratio in the balanced equation. Whatever coefficient that's in front of that that thing in the balanced equation is our mole ratio. And then all of these are just the same thing as what I just listed over here. So we're just kind of going through looking at that. Now, down at the bottom, again, it kind of tells us that 1 mole of something is equal to the molar mass of something, or it's equal to the Avogadro's number of particles of a substance, or it's equal to 22.4 liters. Avogadro is the one that established all of these relationships. So that's where all of this comes into play. Now, the way that I'm going to approach this is we're going to go through and treat this as notes. We'll do some of this together. I'll give you time to work on some parts by yourself, and then we're just going to kind of go through it as we're working. So looking at this, so stoichiometry or stoichiometry, however you choose to pronounce it, is fine. Most of the time, we just call it Stoic just because it's a big word. All right. It's just a fancy word for saying, it's just a fancy word that talks about the relationship between one substance in a chemical reaction to another. All right. So stoichiometry is another way of looking at it is using mole ratio from a balanced equation in one compound in the reaction to determine another amount of compound in the equation. And again, the mole ratio is the relationship between things in there. So we're going to be looking at every section has a model like this for it. So I'm looking at that first model right now. So we have a reaction between nitrogen and hydrogen forming ammonia. When nitrogen reacts with hydrogen to form ammonia, we have a relationship. So for every 1 nitrogen, there are 3 hydrogens, and then there are also 2 ammonias. All right. So the relationship between hydrogen and ammonia is 1 to 2. 3 to 2. The relationship between nitrogen and ammonia is 1 to 2. Relationship between nitrogen and hydrogen is 1 to 3. So we can establish a relationship between any 2 of those 3 things to go from one thing to another. All right. So looking at this and trying to understand what's happening. So first off, let's look at this. So it says, given the following information, nitrogen plus hydrogen yields ammonia. And then it says how many moles of H2 are needed to produce 34.8 moles of ammonia. So in this case, my relationship that I'm doing is I'm going from mole of A to mole of B. When I look at the model, first question asks me, what is the given in the example? The given in the example is that we are starting off with 34.8 moles of ammonia. All right. Now, the nice thing about stoichiometry problems is the moles of whatever you're getting for the given determines your number of sig figs for the rest of the problem. So this is 3 sig figs. Our answer is going to be in 3 sig figs. All right. If it's 2 sig figs, our answer is going to be in 2. If it's 1, our answer is in 1. All right. So now, when we're looking at our relationship here, so they actually give us the example of how to solve this. It says 3 moles of NH3 times, and you'll see that I'll write this a little bit different. Instead of using the little train tracks like they use, I would have written this as 34.8 mole of NH3. And then I'm going to say 3 mole of H2 over 2 mole of NH3. Notice that I'm getting rid of mole of NH3 and I'm getting mole of H2. All right. So those two things say the same thing. But where does the 3 to 2 come from? Where does... Say again, sorry. So if you look in your balanced equation, you have 3 hydrogens for every 2 ammonias. So this 3 and 2 comes from the balanced chemical equation.
How did you get the 1, 2, 3, H2? Never mind, it's obvious.
The coefficients in the balanced chemical equation. All right. Now, what I would like you to do in your calculators right now, I want you to verify that when you take 34.8 times 3 over 2, that you get 52.2. All right. So 34.8 times 3 halves. It's 52.2. All right. Now, so in this problem, bring it here and I'll sign it. You probably need to put your sweatshirt back on because you're out of dress code like that. Okay. Okay. Thank you. All right. So looking at this, what units are we going from and to here? What are the units that we are exchanging here? Moles of ammonia to moles of hydrogen. All right. When you're doing this, it's important to keep track not only what unit you're in, it should be ammonia to mole of hydrogen. It's not only important to keep track of what unit you're in, but also what compound or element you're in at the same time. So you need to make sure you are following through with whatever it is you're using. All right. So keep this model in mind. Flip over to the next page. We're going to do one together, and then I'm going to give you a practice one, and then I'll sign the ones for later. All right. So looking at number 5. Number 5, we are given that 4 moles of phosphorus reacts with 5 moles of O2 to produce 2 moles of P2O5, diphosphorus pentoxide. And so the question asks us, how many moles of P2O5 are formed from 3.4 moles of O2? So what is my given? Where am I starting from in his? All right. 3.4 moles of O2. Now, before I go further from here, sometimes they'll give you an equation that has no coefficients on it. If it didn't have any coefficients, what do you think the first thing you need to verify is? If it's balanced or not. So that's why that was the purpose of last chapter. So you may have to balance these sometimes. They may not be balanced. Sometimes it may just give you the words and you have to write the equation. Sometimes you may have to predict the products. All right, so just kind of keep that in mind. All right, so I'm starting off 3.4 mole of O2. What am I trying to get to? Mole trying to get 2 moles of P2O5. All right, I'm coming from mole of O2. What numbers am I going to put there? What number goes by oxygen here? 5. What number goes by P2O5? 2. Go ahead, see if you can solve it and get your answer. All right, so what should our answer be? 1.4. Why not 1.36? Two sig figs. All right. Now, go ahead. I'm not going to set up B. I want you to go ahead, try to set it up on your own, see what you come up with. All right. So what answer should we have come up with? I get 24.1 because I get 24.08. So I round that 8 up. All right. Now, so that was our examples for mole to mole. All right. So all I did, if I'm looking at my little spider diagram that I had, the little sheet that I gave you, the area that we existed right now on that little spider diagram that I gave you, we just existed right there. All right. Notice that our only conversion was from mole of A to mole of B. In any of the examples, did the pattern change? No. It was always the new substance on top, the old substance on bottom. No. All right. So let's look at number 6. What's different about number 6 than the previous problems? You have to write the equation and balance it. This is a skill we should already have. So let's walk through it. Aluminum. How am I going to write aluminum? What would the formula for copper 2 chloride be? How do I know it's going to take 2 chlorines to react with 1 copper there? Copper is a +2 charge. All right, so aluminum reacts with copper 2 chloride to make, so that's my arrow, aluminum chloride. Am I finished with my equation yet? What do I need to do? Balance. All right, so the only thing that I can start with here is chlorine, because that's really the only thing that's out of balance at this point. So I have 2 chlorines here, 3 chlorines. What's the number that I need to get them both to?
Would be 2Al plus 3.
All right. Not difficult, just a step. All right. Go ahead, try this one on your own.
Oh, I understand. Never mind.
All right. So our given is 6 moles of CuCl3. That's 1 sig fig. What's going to go on the bottom of my conversion factor? CuCl2. And what number should I put there? All right. On top, we're trying to go to AlCl3. And we're going to put 2. So what do we come up with? Should be exactly 4. 6 times 2 is 12, divided by 3 is 4. Questions? Do 6C on your own. Mm-hmm.
So it's asking how many moles were used instead of how many were made.
Doesn't matter.
It doesn't matter.
No, it's just how many. It's really how
Just
many.
how many were made.
The reason why it's asking how many were used is because it's asking for something that's in the reactant now rather than the product.
Hey, does it get more complicated?
Yes. Because we can talk about particles, we can talk about volume, we can talk about mass. All right. So again, the way this packet works, it goes from the easiest type to more difficult. All right. So, what answer should I get? All right, 6.8 mole of copper to chloride. All right, why not 6.75 like you get in the calculator? 2 sig figs. All right, does anybody need to see the setup? Okay. All right, so I'm starting with my given 4.5 mole of aluminum chloride here. I'm trying to get rid of aluminum chloride. So in order to find this number, I'm going to look at my balanced equation. That's 2. I'm going 2 mole of CuCl2. So I'm going from this to this. So I'm able to cancel that now. And then I need to look at my coefficient there. So I'm taking 4.5 times 3 over 2. Notice I started from a different point. My fraction doesn't look the same. My mole ratio doesn't look the same because each one is specific from where you're going from, because you're trying to get rid of that, going to something else. All right. For number 7, that's the one that you're going to have to do on your own at home tonight.
Oh, okay.
So I want to see how you do. That's where we'll start tomorrow morning. Well, not tomorrow morning, but the next time we meet. Or actually, no, I'll probably now everybody in here is going to be taking ACT. So we'll start there Wednesday morning. So I'll be nice and not. But if you want to work on it tonight or tomorrow after ACT, you can work on number 7. You'll have a couple of other things. All right, so now we are looking at Model 2. So just refreshing our memory, what was Model 1? What was the relationship for Model 1? Mole of substance A to mole of substance B. All right. Model 2, we are going from mole of substance A to mole of substance B to mass of B. So I'm adding one step to it. All right. So looking at the picture of our model, what is the given in this reaction? All right, so we're starting from the exact same place that we started from before. Same chemical reaction, so the balance is the same. But we're starting with the same given, 34.8 moles of NH3. All right, so if I'm trying to go from moles of ammonia, notice that this time instead of saying moles of hydrogen, I'm trying to get to grams of hydrogen. But in order to get to grams, I have to go through moles. All right. So where does this relationship of 3 mole of H2 to 2 mole of NH3 come from? All right. So coefficients of the balanced. Come on. All right. Coefficients of the balanced equation. All right. Notice that is these first two are repeated questions. You're going to see those over and over again because it's trying to drill something home. All right. Now, where does the relationship of 2 grams of hydrogen to 1 mole of hydrogen come from? What is that? That is the molar mass. Now, if I was asking you to do this, what would be the difference we would make for the mass of hydrogen? 2.02. All right, so I would actually write this as 2.02 grams of H2 to 1 mole. And so this is the molar mass of hydrogen. How do we get the molar mass of anything? You look at the chart, and since I have 2 hydrogens, I'm going to add 1.01 plus 1.01. That gives me 2.02. So would it be 2 moles equals that? No. 1 mole of H2. I have 2 hydrogens and 1 mole of H2. It's molar mass. We've been doing molar mass for 3 weeks now. Well, don't add anything to it. Don't change how you do molar mass. 1 mole of H2 has 2 hydrogen. Why isn't that 1 mn? When I say that this is 2.02 grams per mole, grams per 1 mole. For every 1 mole, it's 2.02 grams. 1 mole of H2 equals 2.02 grams. Good, I understand. All right. So now, just to verify that, the next question is going to actually go through that. Look at the periodic table. How much does 1 mole of a hydrogen atom weigh? So 1 mole of a hydrogen atom is 1.01 grams. So if 1 mole of a hydrogen atom is 1.01 grams, why is the molar mass of hydrogen, H2, 2.0 grams per mole? Hydrogen is diatomic. All right. So hydrogen's diatomic, so you have H2, not H. All right. Now, I would like for you to not go ahead. So we're going to go ahead and look at the problem here that they set up. So I went from moles of NH3, 34.8 moles of NH3. I went from moles of NH3 to moles of H2. So I did 34.8 times 3 over 2. And then I did 1 mole of H2 is 2.0 grams. And so I got rid of 8 moles of H2, and now I'm in grams of H2. So verify that you get 104.4, and then tell me what they did wrong for their answer.
No, because it is.
Oh, it never.
Yeah.
All right. All right. Now, something else you'll notice if you use the 2.02 like I did, what did it come out to be? Came out at 105. But if you use 2.0, it comes out to 104. The big thing is 3 sig figs. You have to maintain those 3 sig figs on it. All right. Now, active would have had that variance that you could have got away with 105 and 104 as the answer. All right. So just know in my reality, in our class, I want us to use the 2 decimal places on our molar masses. So the answer that I would have been looking for was 105 on this and not 104. All right. On the test, use the 2 decimal places. That's why I teach 2 decimal places, because that's what they use. All right. Now, just going through number 14, number 15, I don't really think I'm going to. So what units is the molar mass used to convert between? All right. Molar mass goes from mole to gram. So moles and grams. Why did you have to start? Why did we have to start with the mole ratio here? Why couldn't I just go directly from moles of this to mass of H2? Because we can't go from moles of one substance to mass of a new substance. We always have to go through moles. All right. So the only relationship that works from 2 different substances is moles of one substance to moles to the new substance. All right. So you always have to translate through moles. All right. Moles is kind of the interpreter. All right. Yes. All right. 16 and 17. 16 and 17, I'm going to ask that you do those on your own for practice before we come back on Wednesday. So 16 and 17, you need to do on your own for practice before we come back on Wednesday. All right. So, Model 1, we did mole to mole. Model 2, All right. So notice this one. I'm going from mass of A to mole of A to mole of B. So I'm starting in mass this time, and I'm trying to get to moles. All right. So looking at our process again, we have the same chemical formula, so it's balanced exactly the same. What's different about my given in this one? Starting in grams. So instead of moles, I'm starting with 34.8 grams of NH3. All right. So now, so looking at the periodic table, how much does hydrogen weigh? 1.01 grams. How much does nitrogen weigh? 14.01 grams. All right, we're going to use that in a minute to get our molar mass. So, determining our, so based off of that information, where does the 17 grams for NH3 come from? That is the combined weight. Because if I have 3 hydrogens at 1.01, that's 3.03. I have 1 nitrogen. So that means that it's 17.04 grams per mole. So 17 for every 1 mole. All right. The 3/2, where does that come from? Coefficients, balance coefficients from the chemical reaction. All right. Molar mass. All right. Where did the 3/2 come from? That's the balance. That's the coefficients from the balanced chemical reaction. Now they want us to double check to see if we actually get 3.07 mole of H2. So I'm doing 34.8 grams of NH3 times and I'm going to do 17.03 in my calculation. 17.04, sorry. All right. So for me, if I use 17.04 like I'm wanting you to do for active and Southeastern wants us to do, we actually get 3.06 rather than 3.07 because we get 3.063. So that's going to be 3. All right. So in this question, why did I use molar mass first instead of at the end like we did before? That's not why. Because we have to get to moles first. Remember, moles is the relationship that we can communicate. I can communicate between moles of hydrogen and moles of ammonia because that's what my balance equation allows me to do. I can't communicate mass to moles, of mass of one substance to moles of another. So I can only communicate from mole of A to mole of B. Of everything that we do in stoichiometry, that's probably the most important thing to remember, is I can only transfer from moles of one substance to moles of another. So we always have to get to moles first. All right. I'll walk through number 24 first. Because I want to save the last one for Wednesday. Yeah. All right. So it says, given the following chemical equation where I have 4P plus 5O2 reacts to form 2P2O5, it says, what is the molar mass of O2? So O2, if I have two oxygens, oxygen is 16.00. So molar mass of O2 should be 32 grams per mole, right? 16 times 2, or 16 plus 16. All right. It says, how many moles of P2O5 are formed from 3.4 grams of O2? So that's my given. Walk me through. How do I set this up? What's going to go on the bottom here? All right, 32 grams of oxygen. What goes on the top? One mole of O2. What's my next step? I should put mole of O2 on the bottom, mole of P2O5 on top. Now I have to look at my equation. 2 of that for 5 of that. Notice that all we're doing is taking the same types of calculations we've done before and putting them together. All right. So 25, you should be able to do on your own. We have time remaining in class. I need you to work on those. I'm going to open up active for chapter 8, and I'm going to figure out which problems you should be able to do at this point.